guys, what's up? This is Alex here again from Advanced Procrastination, and today we got some FIFA action going on here. This FIQ question again, kinematics, is from the 1994 free response questions, which goes to show that when you're studying for the AP exams, don't just look at the most current ones that were released because honestly, the questions can come from anywhere. So, a ball of mass 0.5 kilogram, initially at rest, is kicked directly toward the fence from 0.32 meters away as shown above. The velocity of the ball as it leaves the kicker's foot is 20 meters per second at an angle 37 degrees above the horizontal. The top of the fence is 2.5 meters high. The kicker's foot is in contact with the ball for 0.05 seconds. The ball hits nothing while in flight and air resistance is negligible. So whenever we have a question like this, we know we got components, right? So before we even start, let's sketch out the components. We got our ball. This is our velocity that they give us here. 20 meters per second. And now we know there's going to be a velocity, actually let me change the color here. A velocity x component and a velocity y component. Do we want to change a different color for that? Sure, we'll do that. There we go. So this is velocity y, and this would be velocity x. Fantastic. But we know, I'm going to be switching the colors, lost here. We know that here, this angle, 37 degrees, which means velocity x is going to be cosine 3720, and velocity y is going to be sine 3720, right? We can write that down right now. Cosine 3720. And this is sine. $37.20. Alright, awesome. Now let's get on to the question. Determine the magnitude of the average net force exerted on the ball during the kick. Okay, this one isn't hard. We know that F net equals ma, right? Let's type that out here. F net equals mass times acceleration. So what's the acceleration? Acceleration, we know, is velocity over time. That should give us, in the end, we know the mass, 0.5 kilograms. We know the velocity, which is 20 meters per second. We know the time, right? So we can figure it out. And that should give you, in the end, an F net of around 200 newtons. Done. Solved. Easy peasy. Determine the time it takes for the ball to reach the plane of the fence. So right here. It doesn't matter how high it goes as long as it reaches right there. Okay, cool. Well, for this, we need to know our velocity x, right? Which we do up here. We already determined that. It makes life so much easier. And we know that time equals distance over speed or velocity, whatever. Our Vx here should be around 16 meters per second. Alright, and so that gives us an approximate time, because we know the distance, right? Around 2 seconds. Should we be rounding when we're using the calculations? No, I'm just writing this down for reference. Keep the numbers on your calculator. That's that. Will the ball hit the fence? If so, how far above the top of the fence will it hit? If not, how far above the top of the fence will it pass? Well, right here, we need to use a kinematics equation, of course. I'm just going to erase all this real quick, just so we have space and it's not too cluttered. All right, so we have, now some people use x on the formula sheet, they use x, I'm just going to use d for distance. So d equals our initial velocity times time, I should write it like this, plus half of acceleration and time squared. We should all know this equation, right? Here, however, it's not our initial velocity. We're using final velocity, right? Then it turns into VF t minus 1/2. This should make everything easier. A t squared. That's the one we're using. Okay, well, because it's a projectile, okay, our acceleration is 9.81 or negative 9.81 meters per second squared. You can also use 10. They have a range of correct answers. It doesn't matter what you use, as long as acceptable measurement for the acceleration due to gravity. Our time we solved before, right? Our time was roughly 2 seconds. Oh my god, what the heck? 2 seconds. Okay, now for the velocity here, we need to know our velocity y, right? Because we're looking at the vertical component now. Our velocity y we have over here. And that should give us about 12 meters per second. Okay? So we'll just sub everything in. And once you do, your distance should equal, oh my god, I can't, equal approximately 4.45 meters. Okay? Now it's asking how far above the top of the fence will it pass, because we know this is 2.5. This is way more than 2.5, right? So we'll go 4.45, whatever it is on your calculator, minus 2.5. That should give us approximately 1.95, and then of course we have sig digs, or you don't need this right here. You actually need to answer this in a sentence, right? So the ball does not hit the top of the fence. Rather, it passes, oh my god, I can like semi-type today, above the fence by roughly 2 meters. That's how you answer this question. You still need to show your work here. Now on the axis below, sketch the horizontal and vertical components of the velocity of the ball as functions of time until the ball reaches the plane of the fence. Okay, this isn't bad, because we know our velocity is around 16 meters per second for the horizontal component, for the x component, right? So you just grab a ruler, and we know it only travels 2 meters, right? Now this is a horizontal component, so it should be a nice straight line until I can't line this up properly. There we go. 2 seconds. That's our time right there. That'd be it. For our y component, we know it's around 12 meters per second, and it's accelerating. There's a factor of acceleration acting on it, right? Gravity. So it needs to be going down. Our slope needs to be negative. So 10, 11, 12. We're going down until 2. That's really it. And when they say sketch the horizontal and vertical components, they don't care if you go like this or like this. They just want to see if you have a negative or positive slope. So that was that question. That was really easy too. If you guys have any questions, comments, concerns, hit me up. Again, I'll throw some contact information up here, and we'll see you guys next time.